morning, everyone. Welcome to your last Lab Friday walkthrough. Today, what we're going to be going over is the lab information for Chapter 13 of the price book, which is geodatabases. And what we're talking about today is really the different types of geodatabases and ways that you can manipulate them in a way that actually makes your job easier as you create and develop new data. So, first off, if you guys remember from the lectures that are posted online, geodatabases are technically a type of data format that Esri created as a way to enhance the original type of data format type they had, which was a coverage. But they also did that because when they created shapefiles, which are the green types of layers that you see with the .shp, they originally did that to make them less complex, but at the same time what that did was it actually took away a lot of the information that coverages had, such as topology or other types of behaviors. And so as an answer to kind of fix that and actually develop a way that you could include all of that information plus tables plus any type of network behavior or any type of rules that you wanted to place on the data set, they developed a geodatabase. And as the slides go over, a geodatabase is a way that you can include all of those things in one place. So what we're going to go over today is not necessarily all of the things that you can do with the geodatabase, but I am going to go over different components very quickly. I'm going to go over how to copy geodatabases correctly after you have created one or are trying to give it away to a client or someone that you are giving data to. And then I'm also going to go over two of the main types of behaviors that are probably one of the most useful aspects of having a geodatabase, and that is domains and subtypes. So we're going to start with different types of data within the geodatabase. So we're going to go into Black Hills, which is part of you guys' lab data. And if we open it up, first off, if you notice, the name of the Sturgis 83 geodatabase file extension is .mdb. What that means is that you are actually currently in a personal geodatabase. Now, there's three different types. There's a personal geodatabase, a file geodatabase, and an SDE geodatabase. SDE ones are strictly used on servers, and you guys don't do that, so we're not really going to cover that in more detail, but your book does. But the two main ones that you guys will typically see are personal geodatabases or file geodatabases. And personal geodatabases are small. They can only hold up to 2 gigabytes of data. And then on top of that, the thing about personal geodatabases that are typically considered a weakness of them is the M in MDB stands for Microsoft Access File Format Types. So the way that a personal geodatabase is developed is it's actually based on Microsoft Access. For anyone who's ever used Microsoft Access, it is incredibly easy to corrupt a Microsoft Access file. So part of the reason that most people don't use personal geodatabases in a work environment, not your labs, is because they tend to be very fickle and they are easily corruptible. So even though you are using them in labs, I personally would not suggest it for anything in the work environment. Now, when it comes to a work environment perspective, one of the best ways that you can go is a file geodatabase. A file geodatabase is something that has a slightly different file format ending. So here, once again, RapidNets has an MDB file format. That's still a personal geodatabase, and they probably did this for the labs just so that they could reduce the amount of the size of the data they gave you. But a file geodatabase will have a file extension of GDB. A file geodatabase does not have anything to do with Microsoft Access. It is actually based on a binary code. and that's how it's formatted, and that also makes it harder to corrupt. So typically speaking, if you are working in any type of work environment where you use geodatabases, using a file geodatabase or working off of an SDE geodatabase off of a server are probably your best bets. So beyond that, we're going to go in here and look at what is actually in a geodatabase of any type. When you have a geodatabase, you actually have a lot of different options that you wouldn't normally have if you were just working out of a folder. For example, if you click back, you have these DBF files, and what they are is they're tables. But what you can't do with these is because they're not in a geodatabase, say that gas locations was actually very much related to one of these options. Because it's not in the geodatabase, you cannot actually connect these in a cohesive manner. So if we go back to Black Hills, if we go to Austin GDB, which is a file geodatabase, as you can see, you have featured data sets, but you also have these two tables. These tables can basically be assigned different types of behaviors that also apply to everything else in the geodatabase. Whereas if we were doing just a table that was a standalone in a folder that had a DBF file extension, that would not be possible. So the whole point of a geodatabase is to actually give you the ability to see all of these different types of data, give them some type of relationship between all of them, which is what a feature data set does, and then actually get it into a type of storage capacity where you can literally just copy the geodatabase over and you have the data you need and the behaviors and other types of information you need associated with that in one cohesive spot. Now, geodatabases, because they are made this way and because they are a proprietary file type developed by Esri, means that they are very easily corruptible in a Windows file format. So I'm going to leave this here because I want you to pay attention to this. If you were to go to your Windows file area, and I'm going to navigate to where this data is. Okay, Austin GDB is in this folder, which is the MGIS data folder, and here it is. Now, this is the Windows file system. So this is your computer file system, whereas this over here is what ArcGIS makes files look like through their software. If I were to click into Austin, so this is what it looks like when you use ArcGIS, but if I click it into here in the Windows file, all you get is this very odd folder. Now, I'm already in this folder on this side, so we're going to click into here. And as you can see, these look absolutely nothing alike. The reason that is because the way that geodatabases store all of this information is definitely not something that Windows file format can easily understand. And they do it in a way so that they can keep the behaviors and other types of information that's associated with the data set together, but it also means that the Windows format is really, really clunky and makes absolutely no sense to most people looking at it. What this also means is that it is super easy to corrupt a folder or a geodatabase that is saved in the Windows folder system rather than if you were to do it in ArcGIS. So there's a couple ways for you to actually copy over geodatabases that minimize any type of corruptive problems that might occur if you copy stuff. Number one rule of copying geodatabases is unless you have compressed the data, which I will show you how to do not use Windows file format to copy it. So if I were to literally say copy and I were to paste this somewhere on my desktop, yes, it might work, but yes, it might also be very corrupted. So please don't ever do that. Even if you are copying folders. So say that I am copying the MGIS data folder. If you do not compress that, or you do not do this through ARC, you can actually corrupt every single geodatabase that is within this entire folder itself. So the best ways, absolute best ways to ever copy geodatabases is through two manners. One, if you are giving someone the entire folder of data, right-click and go to Send to Compress Folder. What this means is you are basically compressing all of the data within that folder into a basically little package. So you're putting a wrapper around all of that data to make sure that nothing is left behind. Because typically what happens is when you copy something in Windows file format that contains geodatabases to another location, you can actually run the risk of losing key pieces of data from the file that for whatever reason Windows file system is just not catching, and that's why they get corrupted. If you compress a folder, you're putting a wrapper around everything in that folder, and therefore you are not going to lose anything, and that's really what's important. So if you click Compress Folder, what you should get is something that looks like this. There should be a little zipper along the side of the folder. From here, you can do copy and paste, and you should have absolutely no problems with corruption once that's pasted into a new location. That's how to do this through the Windows file format, which is definitely not the way that I would suggest. What I would suggest is going to ARC Catalog. And if you are ever moving any type of data, always work through ARC Catalog. Now, if we navigate to that same data folder, when you click Open, you are no longer seeing the same level of oddness that we saw with the other GIS folder that we had. So if we go back to Austin, this file format makes way more sense than this one over here. And this is also much easier to copy stuff over with because Esri has automatically developed ARC Catalog and ARC Map to define and collect, or at least identify, every single file type that is associated with this single geodatabase. So if you right click and you say copy, and say you put it up here in E and you say paste, by the time it is done copying, everything from every single little file that might have even been in that geodatabase is now here. So if you look at them, they are exactly the same. So if you are ever copying data where you actually need to give someone a geodatabase, not just a shapefile, but a geodatabase, the best bet is either to compress it, or what I would prefer people do is use ArcGIS Catalog. So that is how you correctly copy a geodatabase over. Now we're actually going to go through the different types of behaviors you can add to geodatabases next, and this is actually what you guys are going over in lab. So I'm actually going to do the first few steps of the MGIS Mastering the Skills section, which is on page 392 of your book. But then I'm going to go over things as much detail in terms of the steps, but I am going to talk to you about domains and subtypes. So what they want you to do is, first of all, they want you to go to the data, and they want you to go to Rapid City, and the first thing they ask you to do is actually make a geodatabase. Now, in here, they actually do what I would prefer you do. They ask you to make a file geodatabase. So now remember, the file geodatabase is the one that is not based on Microsoft Access, so it's typically a better bet in terms of using it for work. So we're going to add a file geodatabase. And we're going to call this RC data. And then the next thing that it asks us to do is figure out what type of coordinate system you want the feature classes to use. Now, if you click on this and go to Properties, you will notice that that is not in there. That is because a geodatabase doesn't actually, a geodatabase itself, so this little thing right here, does not actually store projection information. What does are the feature data sets inside of one. So that would be transportation and utilities. So, however, what is going to occur, and this is where your book is going with the projection information, is what you are going to be asked to do is actually import data from this folder called archive. Whatever you import is what geodatabase projection technically you will be working through. So this one is actually going to ask you to develop a geodatabase that in some way, shape, or form has that information. So there are several things that you can do with the geodatabase. If you right click on one and you look at import, you can import single feature classes. You can import multiple single feature classes. You can import tables. So you could always import one of these little tables down here. And you can even import raster data sets. So it's a pretty nice way to actually store everything in one spot. So now what we're going to do is actually go through developing domains and subtypes for different types of data that you guys actually have in your lab. So I've already developed or created the file geodatabase that you guys are going to need for this, which is RC data, and we're working in the Rapid City database to do this. And we're actually going to make a couple feature data sets that are mentioned in your book that go over different types of subtypes. So the first one is transportation, which is going to have to do a lot with roads. And we want to use NAD 1983 UTM Zone 13. And we're going to have it say finish. So now it's here in our new little geodatabase. And then we're also going to make another one, which is for mainly the subtypes, and that is going to be the water system feature data set. I'm going to write water system. And it's got the right coordinate system. So these are the two main feature data sets that we're actually going to work with in order for me to demonstrate what domains and subtypes are. And these are covered in your book, but I'm going to try and give you guys a little bit more explanation as to why you're doing this. So first off, whenever you have a feature data set, if you just made one, then you actually have to import existing information. So what the transportation thing wants you to do is actually import RC roads. So you want to import a single shapefile. So you go to input features, and this is from the archive. So we want RC roads, and they want us to label this roads. They want us to leave everything else the same. So we're just going to click OK. And we're going to let that work, and we can watch it work over here. So if there's a little hourglass, that means it's still chugging along with the tool. But as soon as this little hammer shows up, that means that the import for the feature class is done. So now we have roads. So what we're going to do next is actually get ready to do something with the water system. Now, this one is different because the water system does not actually have something that we are ready to import yet. It has something that we're going to create later. But in order to create any new type of data, you have to make a feature class for it first. So what we're going to do is say new feature class so that we can eventually edit new information into a feature class. And we want this to be called water lines, which is eventually what we will be making. And these are going to be line features. And so we're going to go ahead and say next. And we want to just say default. And then here, we're not quite ready to work on these because this is actually where we're going to get into subtypes for different types of fields. So for now, because you can go back in later and edit this, we're just going to say finish. Okay, so now we have the two things that we want to be able to work with in terms of domains and subtypes. So first things first is we are actually going to work with domains, because remember, you don't have to have subtypes to have domains, but if you have subtypes, you definitely probably want domains. Make sure that things don't get too complicated once you start editing. Now, what a domain is it is basically stop here. Okay, what a domain is it is basically a way for you to limit the type of attributes certain fields can have when you are doing some type of editing. So what we're going to do is actually go through and do that for roads first, and then we're going to set up subtypes, which are an even further way of making sure that you have stuff categorized in the right way when you make data in the water system. So first things first, we're going to right click on the geodatabase, because that's where you set up geodatabase domains, and you go to properties, and these should not be in here. Okay, so technically you guys should have nothing. I apparently did something wrong. Okay, so now things are blank. First things they want you to do is, for the RC data, they want you to develop a domain name for road type. So you're going to type in road type, and this is the type of road, and the description is just to help you understand how you're coding things. This is definitely text, and because it's text, you automatically only have coded values as an option. Now, if we were to change this to long integer, you could have coded values or a range. If we were to do a range, that would mean that there could be a range of values that your inserted attributes could have. So for example, if you did a range and you said the minimum was 0 and the maximum was 50, the only values you can have are between 0 and 50. However, we're doing road types, so we're going to be doing coded values. When you have coded values, you go down here. So what this wants us to do is make 5 different codes. So ENT, HWY, RMP, CON, and LOC. These stand for interstates, highways, ramps, connectors, and local. Anytime that you do anything with a domain that you are done with, automatically click apply. Okay, so now you have a domain that is part of your general geodatabase. So that applies to everything in this geodatabase. So we're going to go ahead and say, okay, so then what it wants you to do is this geodatabase is going to have different types of information in it. So if you look at your book on 395, there's a table, 13.1, that actually goes through all the different domains that you are going to have within or available for all of these feature classes. So I'm going to go ahead and populate those, and then we'll move on to the next section. Okay, so now all of our domains have been made. So we have directions, which are cardinal directions, and that's north, east, southwest, northeast, northwest, southeast, southwest. We have street abbreviations. I didn't do all of these, but this has the main ones, which is avenue, street, road, or drive. Pipe diameter, that's listed in inches. The material of pipe construction. Flow range in GMP. I'm actually going to go through these. So I went through type of road, which was a coded value, but flow and length load are actually range values. And so according to the book, they want you to do these as a short for this one. And they want the range to be between 1 and 2000. This is how you would do a range domain, not a coded domain. So after you do this, click apply to make sure that it sticks. And something does not match. Interesting. It's probably this one. So now what we want to do is make this one a float, and we want to make this 0 to 9999999. Basically, when you see that number, they're saying that this is a no data value, or they're putting a cap on the absolute highest number that there can be. And I believe that that should be ready to go. The other thing too is, for this one, they do want you to have a split policy. So what they want you to do is give split policy a geometric ratio, and they want the merge policy to be sum values. Basically what this means is whenever you split something within a length float, you are limited by this type of policy, so the way that it's split, and you want sum values, not a weighted average, when you do the splitting. So we're going to click sum values, and we're going to go ahead and click apply. Everything seems to be updated, except for length float. So for right now, since we're actually not going to go over this in this, we're going to get rid of that. But that is how you would actually fill that out when you actually go through the lab. Say apply and say OK. So now, if you were to go back to your geodatabase properties, you should see these domains. So we're going to say OK. Now, the next thing that this wants you to do is actually assign domains and default values. And this is something you do in the feature datasets or feature classes, not the geodatabase. So the first one that it wants us to work on is the roads feature class. The way that you work on domains for specific feature classes in a geodatabase is you go into feature class properties, which is where we are. And we're going to click in here. And as you can see, there is a whole bunch of different types of tabs. And what they want you to do right now is go to fields. These are the types of fields that are currently part of the feature class that we have. So you have prefix, street, road name, so on and so forth. What they want you to do is actually go to prefix and highlight it. And for the domain, they want us to select this. So we're going to highlight this. For the domain, which is right here, they want us to select which domain we are going to identify this field in. So the thing about domains is, say that you are making networks and you need directions for networks, but this could apply to a road network as like what we're dealing with, or a waterline network. Instead of you having to do this for each and every feature class, you just go into the geodatabase like we did originally and set it up there so that when you get to the feature classes themselves, all you have to do is go to the field you want that to apply to. So we're going to go to domain and we're going to click direction. And then for suffix, which is what it wants you to do suffix to, this also wants you to go to direction for the domain. And then for suffix, it wants you to go to the street abbreviation that we wrote in. So avenue, road, drive, things like that. So we're going to click apply. And then we actually, if you look through this, do not have a field called road type, even though we do indeed have a domain that is based on road type. So what they want you to do is actually create a new field. So here we're going to type in road type, and we want the data type to be a text. And we want this to have a length of 3 because when we did the coding, each code only had 3 text characters. And then the domain that we want is actually road type. So this is how you actually take the domains you have already described and apply them to a specific field in every single feature class. The whole point of domains is to make sure that you have a generalized way of doing certain types of attributes without actually having to go in every single time and characterize them based on certain criteria. So for example, road types in this case have very simple categories, and they only fall into 5 of them, which is an interstate, a highway, a ramp, a connector, or a local road. If you know that that is going to be the case in several of your feature classes, if you set that up in the domain ahead of time for the geodatabase, then anytime you have a feature class with that type of information is something that you can literally go into and categorize that right off the bat. So it saves you a lot of time in the future, especially when you're editing. So now what they want us to do is for a default value, they actually want us to write LOC. What this is saying is, say that while you are editing, you did not enter something. What it will automatically do is categorize that new road as local in the road type coded values system. So now what they want you to do is say, okay. So now that has been applied to your roads. And that is exactly how domains work. Now, that is domains. Domains are meant to basically make your life easier. The other thing that is meant to make your life easier is a subtype. Now, a subtype is very similar to domains, but a subtype is just a further way that you can categorize data. And one of the things to remember about subtypes is it has to be categorical data. And that's why we're going to do this on water lines. So what this wants you to do is go to properties for water lines. And I want you to go to fields. Now, as you can see right now, because we made a new feature class, there's nothing really in here beyond the object ID, the shape of the feature class, and then the shape length, since it's a line. What we want to add is line type, and they want this to be a short integer. And then what they want you to do is say apply, because what we're going to do is actually make this a subtype field. Now the way that we do that is going to come up, but first I'm going to fill in the other things that we are actually going to make a subtype for. The next one is pipe diameter, and they also want this to be short integer. And then they also want pipe material. And they do want that one to be text, because when we coded that, we actually did make it a text, and we also only made that with the 3 characters, so we're going to change the length to 3. Now, on these ones, since pipe diameter and pipe material are technically not going to have subtypes, we can set their domain. So for the pipe material, we're going to choose materials, and for default value, it does not have anything, so we're going to say apply. And then for pipe diameter, we're going to choose diameter, because we already know that that is what matches with that field. So we're going to say apply. Okay, so now what we're going to do is actually create subtypes. You do have to add other things, but we're just going to do this for the tutorial's sake. Now what we're going to do is add subtypes for line type. So if you go to the subtypes tab, you want this to be for line type, first off. Now, what this does is it automatically limits what each of those things in this field can be. So literally, if your code is 1, then the subtype for that code is a water main. So the only option right now that you have for this field is water main. Now, that is not the only thing that we have, but there's more to subtypes than meets the eye. Basically what happens with subtypes is you've already made domains for other fields. What subtypes do is automatically populate those other fields, so pipe diameter, pipe material, so on and so forth, with stuff that only applies to that subtype. The way that that works is if you highlight it, what you can actually do is say, this is a water main. The pipe diameter default value is going to be 6. And the pipe material is going to be copper. If you click on domains, it will actually tell you what your options are. So if you say OK, then that tells you what domains you have for that. Now in your tutorial, you will have more that you were supposed to make, but for right now, we're just going to deal with these 2. So now, as we make different water mains, so if we click on here, it did not hold. So as we click on water main, it will hold now. So you always have to click apply. So now we're going to fill in the rest. So now we have 2, which is a water lateral. 3, which is a sewer main. And a sewer lateral, which is 4. So we're going to go ahead and do the domains for these. So for water lateral, so we're going to click apply first off to keep these. So for water lateral, our diameter is 3 and our material is PVC. I'm going to click apply. For a sewer main, the pipe diameter is 12 and the material is concrete. Apply. And then for the sewer lateral, it is going to be 6 and it is also going to be PVC. You're going to say apply. So now when you click through these, all of these values should change based on what you have set them as. So now what this means is if you were to choose or create a water line, because remember this is a blank feature class, if you were to create a blank water line, you would automatically have a default value of 6 in the pipe diameter field and a default value of PVC in the pipe material field. So it's a really quick way to automatically populate data that you are editing, especially if you already know what that should be. So now what this wants you to do is actually click OK to close this. And now what we're going to do is actually edit something. So we're going to go ahead and move this back over here. And I'm going to start editing. And I am first going to edit the water lines because I want to show you how this works. Even though it has you edit the roads first, we're going to do the water lines. So, because this is the only feature that I have listed right now, this is automatically the default for editing, which is why it didn't ask me what I wanted to do for editing. But what Waterlines actually wants me to also do is add the buildings, the connects, and parcels. These were technically imported into your feature class, but I did not do that. You should. Follow directions. Okay, so we're going to zoom into here, because this is where we're going to be doing editing. Now, what this wants you to do, first off, is you're going to be asked to symbolize the different types of water lines by a specific way. So line type at all values. And they want sewer lateral to be that, and sewer main to be similar but thicker. I'm actually going to make this thinner. And they want the same thing with the water mains, except these are going to be red. Okay. So now we have the right symbols for this. So if we click OK, you see that they are here. Oh, these are supposed to be blue. My bad. Okay, so now when we create these should actually be symbolized as either yellow with a certain level of thickness or blue with a certain level of thickness as we create them. So what we're going to do first is go to Create Features. So I want my editing window for Create Features, which is this. And I'm going to be editing water lines, not roads. And I'm making lines. And I want to make sure that when we do the template, the connects and the water lines are what are checked, because the connects are actually how we're going to get to water lines. This is not going to work for me though, because I didn't import these into the Geodatabase, but this will work for you, but for visualization purposes. Now what we're going to do is set snapping, because I want this to snap to the connects, so I want this to snap to points, but I don't want it to do certain things. So right now we're going to turn everything off. And what we are going to do first is make our own water main. So I'm going to pretend that our water main starts here, and I'm just going to make one that goes all the way across the parcels and is as straight as possible. And my computer is a little glitchy, so don't mind this. This is the new water main. If we go to the attribute table for this, it is automatically selected as water main. So now we have a water main. Now what we're going to do, and if you look at this, it automatically filled in the other fields. Now what we're going to do is add a sewer main. So we're going to make another pipe above the water main. And when you go to attributes here, we're actually going to change it to a sewer main. Now if you watch the features over here, they are going to change. And now they're automatically changed. So now, if you were to do connectors, so say we do a connector between this house and we turn on snapping. We want edge snapping. This is not a main, but this is a lateral. So if you go in here, you just turn it into a water lateral. And you say OK. And now when you click off, you should have the right kind of symbology and it's connected to the right spot. So that is what a subtype and a domain is they basically make editing a lot easier when you are dealing with making different types of digitized data that might be a little complex and might have several different types of attributes that you don't want to input every single time. So that is describing attributes and domains. Now if we were doing, that is describing attributes, domains, and subtypes. Now if we were doing roads, so I don't want attributes, if we were doing roads, say that I added a road here, roads would have slightly different things because we didn't give them subtypes, but we would have the ability, see how local is the default? We would actually have the ability to change this to something else if we chose. So that's what having a domain and a subtype do. They give you a lot of editing abilities that minimize problems without making it super difficult to actually go through and change attributes for every single thing you make. And if you are making a utility network or a roads network, that is a lot of little pieces that make up that network. So having this ability to have a domain and a subtype really save you time. So that is the end of our tutorial. If you guys have any questions about this, just let me know. And if not, I hope you guys have a wonderful day.